So hi everyone, welcome to this featured speaker event with Oliva Dsouza, hosted by STEM2girls. My name is Oliva Dsouza, and I will be leading this presentation along with Kara Reen, our president, and Lucia Filter. It is so wonderful to see you all here today. I am so excited to be working with you today. Just a few quick things before we begin introducing ourselves and bringing in our speaker. The session is recorded and a recording will be posted on our website shortly. Please do not record or screenshot this meeting from your end or share the meeting link with anyone else during the presentation. This is going to be a casual Q&A session, and your video will not be seen in the recording unless you are Olivia, Kara, Lucia, or I. We ask that you do not unmute at any time during this meeting, and any questions you have can be asked in the chat directly to us.
So just a few quick things before we begin introducing ourselves and bringing in our speaker. This session is recorded and a recording will be posted on our website shortly, like Jovita just mentioned. So I will begin introducing this organization, STEM2girls. STEM2girls is a student-led nonprofit that empowers girls and women to pursue STEM careers and by providing STEM-related workshops, resources, and opportunities. Despite being a relatively new initiative, we're planning several speaker events such as this one, hosting academic preparation sessions for high school students and releasing videos, as well as presenting opportunities for elementary school students. We're committed to informing and encouraging girls to pursue careers in science, technology, engineering, and mathematics, or STEM. Our vision is to create a world where girls have confidence in pursuing a STEM career, and we hope to do this by providing free and accessible academic resources, hands-on events, and opportunities for girls to connect to professionals and students in the greater Green Bay area in Northeast Wisconsin. I want to bring attention to our website where you can access information about what we do, our lead team, and how to donate to our organization. This is also where we'll be putting updates about future events, including speakers, competitions, and the release of preparation videos for standardized exams. We also have an Instagram at STEM2girls that you can follow to get updates about future events and leadership opportunities. For getting involved, we're looking for passionate students to join our leadership team and contribute ideas. We have an interest form up on our website that you can fill out with information about your background and what you would want to contribute. And this can be anything from web design, social media marketing, and community marketing. We have weekly meetings that you can attend and learn more. And we can also do meetings through Zoom. We have, once again, you can fill out the interest form on our website to get involved, and we look forward to working with you. Once again, if you have any questions during this presentation with Olivia, please enter them in the chat and we can try to answer them at the end. They may also be answered during our presentation.
All right, so now Olivia, you can begin by introducing yourself and sort of what you do and how you are involved in the STEM community.
Sounds great. Thanks for having me, guys. So I am Oliva Dsouza. I'm currently a second-year undergraduate student studying electrical engineering and computer science at UW-Madison. I graduated from Bayport High School in Green Bay as the class of 2021. Let's see. I guess I can start with a couple things I do outside of technology and STEM is that I am currently marathon training. I love to explore little shops and restaurants in Madison, as well as I now work as a barista at a little local cafe close to my apartment in Madison. Some of the big ways I'm involved in STEM at UW-Madison beyond academics is that I am the low voltage team lead for Madison's first solar car team. We are called Badgerloop. A lot of what I do is working on creating circuits and the actual circuit boards themselves that kind of run our car. So we take signals from the brakes, the accelerators, the driver inputs, and make sure those get sent to the car itself. So when the driver flips a switch to make sure the headlights are turned on, when they press on the accelerometer to make sure the car moves forward, those are the circuits I create. I also work on our main circuit board that connects, that takes in signals from all of our other sub teams. So the battery management system, high voltage. So, and we are a solar car. So the solar array, how much power are we getting in from the sun and transferring that to all of our other systems. Also, I am the International Outreach Officer for the Society of Women Engineers at Madison. One of the things we do is that we work to raise money to donate to the Sambali Trust, an organization for girls in India to help provide them with an education as well as STEM training. We're taking on a new project this year where we are working on designing project kits that we will put together and actually make instructions for, make videos, and send it to the Sambali Trust so that they have a more hands-on feel about what engineering really is. Yeah, that's it for my introduction. Is there anything else you guys would like me to say?
That's it for now, and we can move into our questions then. So our first question is, what are some STEM courses and extracurriculars that you took during high school?
Yeah, of course. So in high school at Bayport, we had a pretty well-established AP and IB program. Through that, I took AP chemistry, both calculuses, physics 1, 2, and the C's, as well as bio, stats, and a couple other histories and other humanities courses as well. As far as extracurriculars, I participated in a lot. I was in the chemistry club, academic decathlon. I volunteered through the youth service learning club, as well as I had a great time being a mathlete in the math club. So a little pitch for that if you're not already involved.
Awesome. Those are really great opportunities. So a quick follow-up question. How did these courses and extracurriculars influence you as you decided on a major?
I definitely grew up always loving math and science. Those were just things I'd always been interested in. Space was a big part of my childhood. However, once I got into high school, I realized that it was more than just liking these subjects. There was the feeling of discovery that I gained from learning what does a derivative mean in calculus, or what is mitosis and meiosis, even in bio, and how science and math kind of make up our foundational understanding of the world around us. Being in these clubs and taking these classes really helped me establish that this was something I enjoyed. Although it was very, very difficult at the time, STEM is hard. I definitely realized that the struggle was worth it. And I did switch majors 3 times in the past year, but now I found something that I really love.
All right, and moving on to our second question is, what advice would you give to high school students looking to choose a career path in STEM?
Yeah, of course. I would say take as many science and math classes as you can and just explore the different subjects. Don't pigeonhole yourself to, oh, I'm only going to take bio and chem classes, or I really don't like math, so I'm not going to continue with that. A lot of times people don't realize how interconnected every subject is. You're going to use math in bio and chem. You're going to use it especially in physics and engineering in general. So making sure that you're exploring and taking the time to visit new paths in STEM is crucial just to be a well-rounded scientist or engineer. Find clubs that, I guess my next piece of advice would be, find clubs that fit your passion. You don't have to do everything. You don't have to be involved in like 10 different things at once, but find a place where not only are you passionate about what you're doing, you feel that you can make a significant contribution in that project or in that club or to that team. In doing so, not only is that going to help you build your passion, but it kind of shows your dedication to a long-term project or club.
Awesome. So now we can move into our third question for today, and that is, what were some other prospective majors that you considered choosing?
Yeah, of course. So I jumped all around the board. Before I even got to college application season, I thought I was going to go to med school and I was going to study biochem. So that was a big part of what drew me to science in high school. However, as I realized I kind of missed the math and physics aspect of anything, as well as the space girl that I once was, I definitely applied to many of my universities as aerospace engineering. So definitely engineering mechanics, aerospace, a lot of very heavy physics background. However, I realized I was really interested in the quantum computing field as well. So I decided to make that switch. I still love physics, so I will switch over to computer engineering and tack on the physics double major. As much as I loved computer engineering and physics, I realized that wasn't a field I saw myself in long term after I tried out doing some research in a lab. That was an amazing experience where I realized, hey, this isn't for me. But I was in Badgerloop throughout it all. So I decided the work I do in Badgerloop, designing circuits, doing the math for like power and voltage, and working in a team to create a product that will hopefully move forward, really, made me realize that, whoa, I really do love electrical engineering. I love the hardware, I love the design aspect of it, and it's still very physics based, which is also a lifesaver for me. In doing so, a lot of electrical engineering is being able to understand how do computers work, what code are you writing to like your devices to make them run, which is why I will also be studying computer science, just being able to integrate different fields into one and see it come to life like through a project such as Badgerloop.
Awesome. So that brings us really nicely into our next question, which is, what are some of the projects that you are working on right now?
Yeah, of course. I guess I can definitely heavily go into Badgerloop since I spend about like 20 hours a week working on projects for them. So last year we didn't have a car. It was the first year that we decided, hey, we're gonna build a solar car. So one of the major projects for first semester was designing and creating the foundations of an electrical system. We started out by defining what are the inputs and outputs that we need in our systems. So, okay, there's going to be an accelerometer, there's going to be a brake, right? We're getting in power from the sun. What is that signal transfer going to look like and energy transfer going to look like? Okay, what do we have to send out? We have to meet regulations. Like, what are our lights going to look like? What's the shape of this car? So that was a lot of like building our foundational systems. Also, what circuits am I going to need? So we're going to need a clock on the car. We're going to need an analog to digital converter, converting signals from continuous time waves to discrete time waves. As well as we're going to need to like take power. We're going to be getting 96 volts from the solar arrays and the batteries. Our devices can only use 5. So what are the ways that we're stepping down? 96 to 24 to 12 volts, then 12 volts to 5 and 3.3 depending on the system. So a lot of that was a big planning phase. Second semester was actual design and printed circuit board layout. So once we had our schematics set, it was time to like create the actual circuits that we'd be running all of this information on. So what we did is that we using a software called Altium Designer, we took our schematics and we laid them out onto a circuit board. This involves looking at selecting actual components, like which resistors are going to be best here. What's the circuit? The integrated circuit are like these little microchips that actually are like mini computers. What ICs are we going to need? Which ones meet our needs and which ones are a little bit too expensive? We are a college team, so we have to do that cost benefit analysis. After all of that was planned and the design was created, we actually got the circuit boards in our house. In-house. We call them in-house if that doesn't make any sense. But once we got these circuit boards in-house, it was time for us to actually solder every single resistor and every single device onto the circuit boards. So these included switches the size of the tip of your finger, and that was up to us to put together. After all of that was done, it was time to test our circuits. because sure, we can design it, but do they actually work? We had no idea. So a lot of what we did throughout summer was testing these circuits. And currently, as the team lead, I am working on our second revision. Obviously, with the tests, we realized we did some things wrong, we did some things right. So it's time to redesign, go back, redesign, and make sure that we are working with working circuits, essentially. So that is currently where we are right now. I know that was a lot, but definitely the biggest and one of the best projects I've worked on and am working on at university at UW-Madison. Another project that I'm taking on, and I kind of mentioned this before, is that through the Society of Women Engineers, we are working to plan and create project kits. So what that's going to look like is that we're going to get together and we're going to discuss what are some ways that we can help bring hands-on engineering to the girls in India. This will involve, hey, like, can we send them little breadboards and LEDs and provide them instructional videos on how to wire them up with a battery and so on and so forth. So that is something that we are currently in the planning phase and will hopefully implement as the semester goes on.
Wow, so that is a lot of really amazing projects that you are working on right now. So a quick follow-up question to this is, working on these projects outside of your curriculum for your major, how have they helped you grow your interest and knowledge in engineering?
Yeah, of course. So working on these projects helped me realize what it really means to be an engineer. Sure, I can go to all my classes. I took circuit analysis last year. I know how to calculate power through a resistor, what voltage is being dissipated, and so on and so forth. So, but that's very book-based. Like, sure, I can see these circuits, but when am I ever going to just take a battery and a resistor and just hook it up and measure voltage? Like, nobody's going to do that in their regular life. So being a part of Badgerloop, I was able to take what I've learned in that class and actually apply it to the car systems. Recently, I had to create a circuit for an accelerometer and a gyroscope sensor. But the problem is like, to create the circuit for that sensor, I had to realize what kind of voltage do I need dropped and what kind of resistor do I need to drop that voltage down to either ground or bring it up to power. So taking what I've learned from my circuit analysis class, I was able to realize, like, hey, we're putting in 12 volts and this pin needs to be shorted to ground. I can use 1K, so 1000 ohm resistor in the place of that. I'm not sure those numbers are quite correct. I'd have to look at the schematics, but that's just an example of how we are taking what we're learning about in class and applying it to very practical applications. Badgerloop is run kind of like how they would run an industry. So not only am I working on applying what I learn in class, these are skills that I will be able to take in my future and work when I'm working on maybe boards for an airplane or like an actual car, right? So the best thing about these projects is that it teaches you what it means to be an engineer more so than just being a student.
My phone. Okay, that's better. No.
But yeah.
Okay, before we move on, quick reminder to stay muted during the meeting.
This is good.
Okay, so now we can move on to question number 5, a really, really important question. And that is, what are some of the struggles you faced as a woman in STEM and how have you overcome them?
Yeah, this one might get a little heavy, if I'll be completely honest. So being a woman in STEM and being so focused on like pure science in high school, I came into UW-Madison with minimal engineering knowledge. I really sure, I took circuits in physics class, but I had no true understanding of the practical applications of engineering and science. So coming in, I felt very behind everybody. I'd see these kids, especially guys, who had been building their own electrical bikes since they were 8, working with drones for years, and so on and so forth. So with that came a lot of imposter syndrome. Like, am I really like supposed to be an engineer? Like, they know so much and I don't know any of that. The best way I dealt with that, I think, was joining Badgerloop. Realizing that I can use this as an opportunity to learn rather than pine or mope around about it all day. So definitely feeling like you don't belong is a very prevalent between women in STEM, but taking steps to create that space for yourself is very important. And this kind of follows up with my second point. Being a woman in STEM is that you're constantly surrounded by men. You're surrounded by boys who can be rude. They act like they know everything. And sometimes you start to believe that they do and that you know nothing. But in that case, it's very important to be resilient. And I will be completely honest, I've become almost a callous person in engineering simply because I don't like it when someone actually had an experience last week where I was trying to explain something to a friend and the guy next to me started talking over me, repeating exactly what I said. So, and I just shot him the nastiest look. And yeah, but having to take that and just rather than react to it, you want to respond to it. This means like physically showing like that was not right. Right? This means standing up for yourself. I know last year I had a similar situation where a member of my team wouldn't talk to me at all. He talked to all of the other upperclassmen, all of the other guys, but he refused to acknowledge me as a team member. However, this year, now I'm a team lead. So the important thing to remember as a woman in STEM is creating that space for yourself, because you can't really be quiet. You have to be loud and you have to take up space because they're not going to give it to you. And that's the hardest thing. If there isn't going to be any space and they're not going to make that space for you, you have to squeeze your way in. You have to give yourself a presence, which I understand can be hard for some people. It was really hard for me. But once you get into like the small habit of making sure that you are standing your ground, it starts to become something that you do subconsciously. It's really sad that we have to do this, but it's very important that you do so. Otherwise, you will lose ground, unfortunately. However, despite that, despite becoming a resilient person, it's also important to find your community. Being in the Society of Women Engineers, I have met a community of like women engineers that I can like bring my doubts and concerns to, and they will help me. They will walk me through, hey, like this is a class that you can take to help you with this, this, and this. Or let's say I'll bring up a situation with somebody that we're not getting along. They'll provide me guidance on how to respond to that situation in a mature but resilient manner. So it's important that you find that community, and not even just like in engineering, but finding your friends, finding people that you can just go to when you're having a hard time. That is very, very important. So it's as a woman in STEM, you have to be loud, be proud, but find your community and make sure that you're being able to do so. Another thing is building that mentorship relationships. Being in Badgerloop, I was lucky enough that Badgerloop, for the most part, the leadership team, when I was a freshman, was very understanding and communicative. They made sure that they explained that even the simplest circuits to me, someone who had no engineering design experience. This year, as a team lead, I feel that I can go to them with beyond just design problems. I can ask them questions like, hey, I'm an electrical engineer. Is this a good internship offer? Is this something that will help me in my career? Because they have gone through it. So finding your mentors, finding your community is another very, very important aspect of being a woman in STEM.
Wow, so that was a really, really great answer. There are a couple questions that I kind of wanted to touch upon before we move on, that I thought were really amazing. So do you see any, are there any strengths that girls have in this, in your area of research?
Yeah, especially in electrical engineering, I think you want to simplify what your designs are. And this works to any type of engineering or any type of like research in a field. Yes, you want to get the most effective, beautiful answer, but you don't need to create something overly complicated to do so. I've found that a lot of women in electrical engineering have found ways to take the most simplest approach. A lot of guys love creating very hard, very difficult problems, which is great. Like it's fun if you just have to have a challenge, right? But when it comes down to it, I don't need a triangle of resistors when you can just use one. I don't need you to, I don't need to be taking in all these signals when we can separate it and just send it through a serial communication interface, which probably doesn't make any sense, but it's essentially breaking down very hard tasks into smaller problems. Especially being women, we have a tendency to stay organized, and that is crucial, very crucial in project management. So being able to take your tasks, delegate them efficiently and effectively is what makes us really good engineers beyond just teammates. Beyond that as well is that because we have a tendency to form communities more than, for example, guys do, there's a lot more team spirit, I found. Being a team lead, there's only me and one other girl who are team leads. We've taken it upon ourselves to create like fun events, like have fun during meetings. Sometimes people are very like straight to the point, and that can bring others down. So being able to create that community and create project teams to create, let me try to word this right, to form project teams that are more than just teams. They're friends, they're runners together. I run with Badgerloop people all the time. Their mini community in their own is crucial because you can only have a good team if you guys understand and work with each other. So definitely, now this might seem like I'm talking a lot more about like the soft skills of being a woman in STEM, but that is so crucial in these environments.
Okay, and our next question is, what resources are there for women in STEM at UW-Madison?
Yeah, of course. There are so many resources for women in STEM. I'll just start off right away with the Society of Women Engineers, right? Finding that community is a resource in itself. And we have about over 100 members, all from all different majors. So having people to talk to is very important. The engineering college, College of Engineering at UW-Madison also has a ton of equity and diversity resources. We do have a department called the Inclusion, Equity, and Diversity, IED, Inclusion, Equity, and Diversity Education at the College of Engineering, so IEDE. What they do is that they host various events, not even just for women in engineering, but diversity orgs and minorities in engineering themselves. So they'll host Women History Month lunches, Latinx History Month lunches. They'll have certain events where you can just come and meet other people. So a center like that, they also have opportunities for you to go in and talk to a counselor, talk to a professor, talk to the dean of diversity in the College of Engineering to bring those issues up and address them as well. Next of all, one of the most important things at the College of Engineering is engineering career services. Oftentimes we can think that we know everything. Our resume is perfect, our job applications are on lock. We don't have anything. However, the engineering career services at UW-Madison really works to they will review your essays, they'll do interview prep, they'll help you decide between offers for internships or co-ops. So that is a very important resource, especially for me who came in to engineering, not really knowing what I wanted to do with my career or what that even looks like for a sophomore electrical engineer. Like, what am I supposed to look for in an internship? So on and so forth. And being able to recognize, hey, like if you put this on your resume, you might get a job in this field. If you put this on your resume, you might be able to get a job in another field. So being able to recognize that, they have those people to do so at the Engineering Career Services. The next resource in itself is just passion clubs and projects. This goes back to like SWEET, building community, building that passion will help you network, especially network. And that's one of the biggest reasons for joining these clubs and projects. The next part would be just overall wellness groups. University Health Services, as well as the College of Engineering, put out well-being resources every month, as well as have opportunities to sign up for group mentoring, where you don't really, it's not a therapy session, but you guys work together to set goals, to say, hey, like I want to work on this, and this semester, and we'll hold each other accountable. So resources like that are also widely available at UW-Madison. The final thing I wanted to mention as far as resources go is that STEM is hard. I definitely struggled in classes my first year. It was a lot more studying than high school, and I had to do so in a more effective manner. So, and there were times when I would go to lecture and I would leave lecture not knowing a single thing. I had no idea what happened. Not that I fell asleep, like I paid attention, I took notes, but I just left feeling so confused. That's why the College of Engineering at UW-Madison has the Undergraduate Learning Center. So it's a free tutoring resource that takes place every night, every evening from Sunday to Thursday, where they will provide free tutoring for almost all classes for your first 2 years of any engineering major. I was in there for differential calculus and linear algebra last semester almost every night, or at the very least twice a week, just to get extra guidance and extra assistance on my work. And in a environment to do so where not only am I working with a tutor, I'm also working with other students in my class. So we're helping and teaching each other, which is so important once you get into college. So yeah.
Of course. Thank you so much for providing with us with those resources. So now we do have a couple of really great questions that people have entered in the chat. And some of them being sort of related to the same topic, I suppose. So what kind of jobs can you do with your major? And specifically, what kind of jobs do you want to have? What job do you want to have?
Yeah, of course. So being an electrical engineering major, I can do almost anything, really. So one of the offers I was given this year was to work on design and layout for Georgia Pacific. So that would be me working on schematics and electrical designs for their devices and so on and so forth. Another offer that you can go for is like designing watches. What's the circuits within an, not even just an Apple Watch or like a smartwatch, but a basic like your Rolex. What are the things that go into there? So those are very more like physical things, right? You can take that to a bigger scale. So on Badgerloop, I'm working on car electrical systems. Now I can take this knowledge and apply it to at least, and this answers the question of what I want to do, is that I want to work on flight control systems for like spaceships and planes. So that's something I can take, and it's a great example. I can take the control system essentially that I'm working on for Badgerloop and apply it to these very large scale fields. I can also take that same experience, I'm working on a solar car, and apply it to another automotive company. Say Ford, for example, if they need a new electrical design system designed for a car, or they needed revamped new circuits, right? I can take what I've learned in these classes and apply it to that. On the other end of electrical engineering is something that we don't think about every day, is microelectronics. So all the circuits that I've been talking about actually have a little chip. So those are called integrated circuits. So circuits within circuits in these tiny little like square packages. Your computers have hundreds of them. Every device has many of these. And these are circuits that have been placed using lasers onto like little tiny silicone wafers. So that sounds more like physics and science, right? but that's something I'm taking classes in as an electrical engineer and something I could work on as an electrical engineer. So there's especially, and that's what I love about electrical engineering. I can take classes in and study everything from the smallest technologies to some of the largest electrical systems. Not only am I talking about like cars and planes, but wind turbines, generators, power networks. So that the best thing about electrical engineering in any engineering field is the wide variety of fields, jobs you can get simply by having this education and having this knowledge.
That's amazing. I love to hear about how applicable engineering majors are, just how you can just implement them in so many different fields. Another set of questions that we were asked is, how many girls are in your area of study, and have you had the opportunity to work with them a little bit more in depth on some of these projects that you're working on?
So this is the kicker. I am currently the class of 2025 for UW-Madison's College of Engineering. There are 5 girls in electrical engineering in the class of 2025 in the entire University of Wisconsin-Madison campus. I am very lucky that I know 4 of them, and I am yearning to meet the last one. So, there's 6. No, there's 5. I've met 3 of them, and I need to meet 1 more. I forgot about myself. So that was a really big shock to me. Electrical engineering is one of the lowest is a field that has the lowest percentage of women engineers. However, don't let that deter you. I'm doing great. Computer engineering, chemical engineering, biomedical engineering, they are almost nearly 50 to 60% women, which is great. Mechanical engineering is also about 40% women, and engineering mechanics, engineering physics tends to be close to the electrical engineering side of things. So that despite having such large numbers, it's hard. It's hard. I find it difficult to kind of make electrical engineering friends because I already know 75% of my class of women in electrical engineering. However, I do get to work with them in projects a lot. As I mentioned, I'm the low voltage team lead for Badgerloop, and my friend Sarah, who's also electrical engineering computer science, she's the high voltage team lead for Badgerloop. So we work very closely on making sure our systems integrate. We also have tons of classes together. Another good friend of mine, electrical engineering, Sydney, we have a ton of classes together. So you will have classes together and you will meet other people in your major. Another thing I will note is that the first 2 years of electrical and computer engineering are pretty much the same curriculum. So I have met so many other women in engineering, but they're just computer engineers, which is okay because we have these classes together, so we can still build these friendships and work on similar projects in class and out of class. There are women who've joined my team this year for low voltage that they're actually computer engineers. So, but they're still interested in this hardware side of things. And you can take anything that you do in electrical or computer and apply it one way or the other, which is great.
That is so inspiring to hear. Another question that we have just received is, can you talk more about the project kit with the trust and what it is that you're doing?
Yeah, of course. So this is still definitely something that's in the works. So we're beginning a set planning phase over the next 2 weeks, actually. So what we're planning to do is that in previous years, a lot of what we had done was just raise money and donate it straight to the Somali Trust. And while we want to continue doing that, we realized that it's still there's still a disconnect between us at UW-Madison and the girls at the Somali Trust. So one way to kind of close that gap is to be able to provide them with a simple STEM education ourselves. And with the time difference and the distance, it's very difficult to do so. So I came up with the idea of working on these project kits. Like I mentioned, what we're going to do is that we're going to design projects and buy the materials and assemble these kits to send to the Somali Trust. However, along with each of those kits, we will be providing instructions, lesson plans, as well as like an instructional video on how to work through the project and what are the takeaways from that project. We're also hoping to kind of create two different versions. So a more involved, harder version for some of the older girls, and a more simple, but still just as fun version of the project for the younger girls. We're still deciding on the projects since I have had an interest from a variety of different women in different majors. So we're still deciding, hey, do we want to take this more of a mechanical engineering route, electrical? What are ways we can combine them? And those are discussions that will be happening soon.
That is some really amazing work. I'm so glad to hear that you are able to do that. And if there are no other questions, I would like to thank everyone for joining us today. Thank you so much for listening. And Olivia, thank you so much for your valuable insight into the field of electrical engineering and sort of the curriculum at UW-Madison. I'm so happy to hear from you. And we wish you the best of luck in pursuing your major and any other future career path that you choose.
Yeah, of course. Thank you guys for having me. And I also just wanted to note, if you guys have any more questions or want to ask me anything else, I think Jovita can provide you with my contact information. And yeah, I'll feel free to like email me and I will 100% respond.
Of course. And on this slide, we have some additional information with our contact information as leaders of STEM2girls and the STEM2girls general email, some information about our interest form and donation information. And if you would like to have Olivia's contact information, feel free to message us in the chat and we can provide you with that. So once again, thank you everyone for joining us, and I hope that you guys got something out of this amazing Q&A session. Thank you so much.
Thank you.
Thank you, Olivia, so much. I learned so much about electrical engineering and the resources there. So I'm really glad you spoke for our first event.
I'm glad. Thank you guys so much for having me. It was a ton of fun.